Hello and welcome to the Digital Insight, the technology and supply chain podcast that delivers valuable C-level perspective into the core issues surrounding business transformation and digital disruption. Each episode will bring you the most inspiring executive insights from those leading transformation strategies within the world's biggest and best-known companies. The Digital Insight. Disrupt, transform, evolve.
Hello and welcome to Digital Insight, the podcast from CPO Strategy and the Interface magazine. I'm Jason Walsh. Today we're joined by Dennis Hodges of Inteva Products, a major supplier of interior components to the automotive industry. And we talked to Dennis about the raft of changes that industry is undergoing, particularly on the production side of things. Just one word of warning to listeners. Dennis joined us by mobile phone, so apologies for slightly compressed audio.
So the automotive industry is one that has been going through some very radical changes in the last number of years, with even more radical changes expected. All of these driven by digital technologies, whether that's in the automobile itself or ideas around self-driving cars, 5G networks and so on. Do you think that this is an area that has been ripe for digital transformation?
Yes, I do. I think that it's about time. And we're an auto supplier, but looking at it from the auto side, the concern I see from an IT perspective is cybersecurity within the car. The electrical engineers are so bent on what they can do. Sometimes I don't think they think enough about what they should do and how to protect what they have.
I see that in your own business you've changed your ERP system. I mean, what was the motivation behind that?
It was more automotive focused and it was much cheaper.
And is it a cloud-based system that you've moved to?
It is a cloud-based system. It's a service, software as a service.
And was this an idea of moving things from capital expenditure to current, or was it really about getting more from the technology?
It was really three things: getting more from the technology, moving CapEx to OpEx, and getting a better solution for our business.
And it's specialized software. What are you actually using?
It's called Plex, P-L-E-X. It's an ERP system for manufacturing, and there's a couple of others, smaller verticals that use it, but primarily it's for manufacturing, and a lot of automotive suppliers are moving to it or already have it.
And you're supplying yourselves to major automotive manufacturers, but you're producing closure systems, interior systems, motors, electronics, roof systems, and so on. So, I mean, I guess you're taking in quite a lot of components from companies yourselves.
Yes, we are a manufacturer of some components, and then we buy other components from suppliers, and a lot of the final assembly is done in-house.
And is it a particularly complicated supply chain, given the nature of the products you're making and, of course, all of the safety regulations around automotive?
Yeah, it's not only complicated because of the safety regulations, but it's very much a global supply chain.
Okay, so you're taking in from, most of the continents, yeah?
Yes.
And who are you supplying to?
All of the large OEMs globally, including a lot of the local Chinese OEMs.
Okay, Nanjing Auto and Shanghai and so on.
Yes.
So tell me, how have you found their experience on this kind of back-end technology? I mean, obviously your company has been able to make this leap into the cloud. Is it acceptable to them, or are they still looking at more traditional systems?
I think a lot of the OEMs are still looking at more traditional systems because a lot of them are just so much bigger. And, our job is to be the nimble organization that can supply parts to them, faster and cheaper than they can do it themselves. A lot of times, I certainly won't say better because I don't think they would ever agree with that, but I think faster and cheaper would definitely be words that they would use for why they use tier ones or tier twos in the first place. But I would say that the key really comes down to the ability, especially now, the word Takata has entered the dictionary, or at least the local vernacular, as something terrible. And warranty and recall really are, Takata, that was kind of a to me a watershed in that all of a sudden we were being asked to do traceability on parts that maybe we'd never been asked to do so much detail on before, even though they weren't necessarily safety related. But an airbag, of course, should have been monitored all the way through, but I guess they weren't doing a very good job of it before. But, we're now looking at being able to, we produce, like in our instrument panels and our door trim for vehicles, we take raw pellet, turn it into a finished product with, of course, other components coming in along the way. But we have traceability back to basically to the silo in the rail car that the pellets came in.
And I mean, is there a predictive maintenance aspect to what you're doing? And if so, is that in the manufacturing process or actually in the components that you're supplying into the manufacturers?
As far as predictive maintenance for our components we supply to the manufacturers, the plan is zero maintenance ever required. With sunroofs, of course, they're unique because they are much, moving parts, very complicated. But a lot of our other products, to replace the interior components is very much less of a moving product, things like that. But door latches and motors even, the plan is to never do that. Now, for us, what we're trying to do with basically the industrial Internet of Things, which we're working with to look at both sides of the operating equipment now. To injection molder, for example, $1 million piece of equipment. Not only do you care about the production side of that equipment, you also care about the internals of that machine, whether it's oil temperature or just other operating parameters. You want to start tracking that so that you can start seeing that even ambient temperature, things that you can start seeing that when we have a 90-degree day with 90% humidity in Mexico, production is going to be up or down based on, as we see that as a trend, we can start preparing for it. So that we know that in the summer we may want to run more shifts at night than we do during the day when the temperatures are cooler. Little things like that really go a long way for us.
So what kind of connectivity is your industrial Internet of Things working on? Is this fiber broadband, or are you using a specialist radio network like Sigfox? Because, I guess the actual quantum of data that you're dealing with is quite small, but you need it to be constantly online, constantly giving information to the right systems.
Right, and I would say that most of our data at this point is still gathered via the older traditional methods, particularly on the operating equipment itself, whether it's Kempware or some other still even serial interfaces into the older equipment. Now they're connected via Ethernet or in some cases via wireless. But it is amazing the amount of data that can be generated when there's like 30 parameters being read every minute, for example. It's not a lot of data at a time, but if you try to keep historical trends, you really do start adding up to a lot of data.
Yeah, the aggregate actually becomes quite large.
The aggregate becomes very large, yes.
So, in terms of transforming the business digitally, it sounds to me like there are two very distinct sides to it. One is the business of being a business, so looking at things like ERP, financial consolidation, any business intelligence systems that you're using, and then the business of the business that you're in, which is the industrial Internet of Things, looking after the manufacturing process. Are transforming these with new technologies fundamentally the same process, just applied to different aspects of what you do, or do you have to approach them in different ways?
Well, we try to do things incrementally and evolutionary rather than revolutionary. Especially, I keep harping on this equipment that's multi-million-dollar equipment. You're not just going to replace it because there's a better way to connect to it. But as we start bringing in new equipment, we are part of the conversation with the mechanical engineers, manufacturing engineers, that what is your long-term goal for, for monitoring both sides of the piece of equipment, for example. But, we're trying to make it where we can move a line within a plant or between plants. So you really don't want to hardwire anything you don't have to anymore. So the wireless technologies, but I call most of these manufacturing facilities gigantic Faraday cages because there's so much steel around that it interferes with signals. So trying to build in that environment, that's where I've kind of said it about a couple of friends laugh when I tell them because they're in the same world as me. You have the Internet of Things, which is to me the consumer world, and where Silicon Valley's really impact, looking at and trying to impact that. The industrial Internet of Things is a little grislier because you're running in that kind of environment where oil, grease, and steel are in the way of everything. So it's not as clean an environment. So trying to make things work the same way is more of a challenge, put it that way.
But when you get it done, when you've moved away from hardwired connections, I guess it allows you to scale up and scale down production according to, consumer trends or, what your customers want.
Right, where we can, let's say that this line, you could move a line more quickly, not that you would move a line, every other day or something like that, but the ability to move it to another part of the plant without rewiring, dropping $50,000 or so just to put in some more wiring. If you're going to do that a couple of times a year or so you do that for a 1 million square foot plant, you could be looking at doing that 10 to 15 times a year. Now, 10 times 50,000, you're throwing away $500,000, whereas if you could have done it with, as we get towards 5G and the saturation of that kind of technology is really where I see the world going.
I mean, also, I see here in my notes, and this sounds like a small thing, but I imagine it's actually not. You have access to digital copies of the manual, allowing for real-time diagnosis of any of the plant equipment.
Yeah, and the goal, what we do now is the mechanic or the millwright may go out to a piece of equipment, and rather than carrying the manual with him, he's now got it on a tablet. So, but the goal, if Google Glass is still not come really as far as we had hoped, you'd be able to go out there and basically using Google Glass, you'd be able to be looking at the piece of machinery, nothing in your hands to distract you from using two hands for a wrench, because you got the tablet, you got to find a place to sit it. Yeah. But if you had Google Glass, you could actually be looking at the equipment and looking at the manual at the same time.
Yeah. Now tell me, when you have a cloud-based ERP and you effectively have cloud-based manufacturing, if you like, because the industrial Internet of Things is fundamentally about feeding the data into the cloud, is it really being driven by real-time reporting? Is that the ultimate goal? You want to sort of have a super just-in-time production process?
Well, what I'll say is we are discrete manufacturing in that we are making parts to a requirement from a customer, but a lot of what we make, I can't say that anymore. Latches, it would be that way because you're making on one line 1 million latches, that are all the same. Maybe 10 million latches that are all the same. On some of these other parts where we really have started adding what we call our Inteva control panel, which is that interface between the manufacturing execution system and the ERP, that's sitting at the operator interface. So the operator is actually seeing that. The shift supervisor is seeing a big screen television with a Raspberry Pi connected to it that's showing them operating equipment efficiency, it's showing them first-time quality, it's showing them downtime, showing them production per hour in real time. So the shift supervisor walks by, everybody knows he's going to see that we've not made what we were supposed to have made today so far. He can go ask the team leads and the operators, what's causing the problem. But the downtime, we're actually able to enter the downtime in real time as well, so that the ERP captures it, the MES knows it, and the operator and the shop floor all see it in real time.
The other thing is you're operating in 18 countries, and of course having the ability to interconnect is obviously going to be very useful for the business, but I imagine you run into sort of quite significant variances in connectivity.
Inside the plant, no. But yes, if you start talking about going outside the plant, or even sometimes connectivity back to the ERP used to be a problem in some locations that we've been able to fine-tune that to the network. But inside the plant, it's pretty compatible globally.
Yeah, and it's effectively wireless, industrial strength, so to speak.
It's effectively wireless. That's what we're trying to drive to as much as possible, yes.
Dennis, thank you for joining us.
Sure.
Thank you for listening to the Digital Insight Podcast in association with theinterface.net and cpostrategy.com. The Digital Insight is brought to you by B2E Media Limited. We hope you enjoyed this episode. Please remember to subscribe, rate, and review, and don't forget to check out our podcast archive at www.b2e-media.com/podcast.